The swing-tail military turbojet transport proposed for the Air Force turbojet transport system is similar in appearance to its celebrated sister, the Convair 880 commercial jetliner. The military 600 swing-tail jet transport measures 139 feet 2 inches in overall length and 39 feet 4 inches in overall height, with a wingspan of 120 feet. It is designed to provide rapid movement of payloads on intercontinental and transcontinental routes at all latitudes and in all weather. Initial development of the Convair 880 and 600 jet aircraft began as early as 1956. This program, undergoing continual investigation over the past 3 years, has ranged from testing of parts as small as a bolt to exhaustive underwater pressure cycling investigations conducted on a complete jet airliner fuselage. Here in the Convair San Diego Engineering Research and Development Center Structural Test Facility, 880, 600, and military jetliner components are undergoing continual test investigations. In the wing lower surface splice testing jig, an 880 lower wing splice was subjected to test stresses far in excess of any that are encountered under normal operating conditions. Earlier static testing of a similar wing section withstood loads that produced stresses in excess of 46,000 pounds per square inch. The normal operating range is from 14,600 pounds per square inch to 22,200 pounds per square inch. Fatigue tests on this section involved cycling under compression and tension loading. This section was subjected to over 400,000 cycles, simulating more than 20 years of rugged medium and short-range operation with no damage resulting. A highly satisfactory demonstration of the quality built into every Convair jet airliner. In the flap track testing program conducted in another area, a similar 400,000 life cycle investigation was accomplished. In this test, loads affecting the spar to which the track was attached were originated by a special hydraulic loads simulator. A 1 3/8 deflection at the end of the track duplicated actual track movement under normal aircraft operational conditions. This program was completed with no structural failures. All the basic structure testing conducted on the development of components is observed and recorded by inspectors from the Federal Aviation Administration, and structural approval is granted well ahead of the flight test program. In another area, preparations were made for exhaustive pressure cycling of a cockpit section in a water-filled tank investigation. Completely submerged in water, the section was alternately pressurized to 9.6 pounds per square inch, well above normal operating pressures, and then depressurized. This highly satisfactory program was accomplished in a 50,000 cycle investigation that simulated a lifetime of flight operation. An example of the detailed testing accomplished in the test program is demonstrated by the tests being conducted on the new window panes designed for Convair jetliners. Composed of a new plastic called Stretch Plex 55, it resists craze or vertical cracks experienced in older types of airliner windows. The windows with damage deliberately inflicted are cycled under pressure in a test that demonstrates these highly desirable qualities. At the Thompson Products Full-Scale Fuel System Test Stand in Inglewood, California, an investigation to verify wing fuel system performance was conducted in a complete simulated wing section. A full-scale partial left wing was constructed especially for this program. It contained both the integral replenishing and main tank. Completely outfitted with all normal plumbing and routing systems, including the engine-driven fuel pump. Tests were conducted at altitudes ranging from sea level to 40,000 feet. All attitudes of dive, climb, and level flights encountered in the normal operation of a jet transport were simulated mechanically during these tests. Over $186,000 was spent on this test to verify the design and operational standards of the fuel scheduling system. In Plant 1, San Diego, all engineering, planning testing, sub-assembly manufacture, and major component sections are assembled into the completed aircraft on assembly lines capable of producing as many as 7 different versions of the Convair jet transport each month. This is an Urco automatic riveter, the most advanced automatic riveter ever manufactured. Especially designed and built for the jet transport program, its job is to rivet and finish entire wing and skin panel sections with a revolutionary new precision accuracy, an accuracy that is as advanced as the jet transports it helps to build. It can select from 3 different length rivets and perform these operations automatically from a photoelectric template. 4 of these machines have been installed at a cost of over $400,000 in order to help meet the needs of the enormous production schedules of the Convair jet transport program. Once the wings have been constructed, they are cured in the mammoth Scotch weld oven, a process that completely seals the integral wing fuel tanks for a lifetime of trouble-free service. Following a pressure test that ensures quality in construction, they are lowered to the first assembly platform, where they are joined and become the airliner's backbone, ready to receive additional major assemblies as it moves from station to station in the assembly lines. Being assembled along with other flying versions of the jet transport is a special full-scale fuselage that will be pressure tested to destruction in order to fully investigate the superior quality of fuselage construction. This full-scale fuselage assembly will have stub wings so that it can be entirely submerged in water in a huge tank built especially for this purpose. This will be the first full-scale jet transport fuselage and wing center section test of this magnitude ever conducted in the United States. This fail-safe investigation will demonstrate through exhaustive pressure cycling the high standard of quality built into every Convair jet transport. Now beginning construction in the manufacturing area is the Convair 600 commercial jet airliner, sister to the military jet transport. These aircraft, primarily designed for medium-range service, are ruggedly constructed to withstand grueling punishment inflicted through repeated landings and takeoffs, a design not required for longer-range aircraft. In addition to being strong medium-range transports, both are capable of serving short and intercontinental routes. Convair's Basic 600 is the first jet aircraft designed with turbofan engines, and in the military version will carry 150 troops and personnel equipment. Converted for air evacuation, it will accommodate 60 litter patients with additional seats for 15 ambulatory patients plus attendants. As a cargo carrier capable of carrying maximum payloads of over 70,000 pounds, it will transport a cargo payload of 50,000 pounds, a distance of 3,500 nautical miles, or a payload of 20,000 pounds for 5,000 nautical miles. Complete off-on loading, including servicing and refueling of the airplane, can be accomplished well within time limit requirements. The Convair 600, now in production, when modified with the swing tail and cargo floor, will perform all turbo transport system requirements specified by the United States Air Force.